So this is your quadratic formula. If you don't have it, make sure you get it. All right, make sure you have it written down and you know how to use it, okay? So, number 6. What does number 6 say, please and thank you? Okay, so whenever you're solving these, the first step is you have to be in standard form, which means ax squared plus bx plus c equals 0. Am I in standard form, yes or no? Yes, okay? So there's no major work for me to do before I can do some work. So what's my A? What's my B? And what's my C? 7. Okay. So now all you do is plug it into the formula. So I get negative of B plus or minus the square root of B squared minus 4 times A times C all over 2A. Now, you got to be careful. When I had students in first and third hour coming up today, a lot of them were stopping the radical or the division bar here. It's the entire numerator. Okay, that includes the negative 16. The negative B, that's on top of the division bar as well. So that division bar needs to run the whole way. It's more than just a semantic thing like, oh, the math teacher's just making me do extra work. No. If you don't have it like that, you're actually changing the entire value of the problem, and you're no longer finding solutions, but you're finding the wrong answer. Okay, that division bar needs to be there. Everybody okay, yes or no? All right. So now we start simplifying. So what's the opposite of negative 16? Positive 16. What's 16 squared? 256. No, it'll be positive. Negative times a negative is positive. So this number should never, ever, ever be a negative because it's b squared. That's why I use parentheses here. Okay? So what is negative 4 times 1? Negative 4. Negative 4 times 7? Negative 28. All over 2 times 1, which is 2. All right, what's 256 minus 28? 220 what? 228. All over 2. Now, is 228 a perfect square? No, so we have to find... That's going to be gross. All right. So in order to reduce this down, we need to find a number that's a factor of 228 and also a perfect square. Okay? Now, you can start in the basement and work your way up, or you can start at the top and work your way down. I'm going to start in the basement. So I'm going to take my 228 and divide it by my first perfect square. What's my first perfect square? 4. And I get a number. I get 4 times 57. Now, instead of going with 228 all the time, I'm going to actually use 57 because it's smaller. Everybody okay with that? So if there's another perfect square or another multiple that can come out of 228, it'll also have to come out of 57. Is everybody okay with that? Yes, no? So 57 divided by 4, does that get me a whole number? No. So I'm just going to keep working here. 57 divided by 9 does not work. 57 divided by 16, said 16, not 16. That doesn't work. 57 divided by 25 definitely won't work. 57 divided by 36 does not work. And once you get past the 2, right, like if you notice, when I take 57 divided by 36, I'm past 2 on my number up here, right? If you're smaller than 2, then there's no other number that's going to work unless the number you're typing in itself is a perfect square. Okay, unless 57 is a perfect square. Everybody okay with that, yeah? Okay. So I get 4 times 57. Now, the reason why I'm doing this is I cannot reduce anything as long as I have that radical around. So what I'm trying to do is find a number that I can pull through the radical in order to make the number under the square root sign smaller. So what is the square root of 4? 2. So a 4 inside a square root becomes a 2 outside the square root. Is everybody okay with that? Yes, no, maybe? And as long as this 228 is under the radical, there's nothing I can do to reduce this. Okay, you can't divide a number inside a square root with a number outside the square root. Everybody okay with that? Because like square root is a function, so it locks everything down, just like when we had parentheses. So now is there anything that I can do to simplify up here? 16 over 2, can that get smaller? That's 8. What about 2 over 2? 1. So I get 8 plus or minus the square root of 57. And this is your final answer. Everybody okay? You think maybe, possibly, I don't know? Okay, with which part? Where? So are you okay with getting to here? Okay, so we need two numbers that multiply together to get 228, but one of them is a perfect square. So if I take 228 and divide it by 4, I get 4 and 57. So that one works, right? But I want to find the biggest perfect square. So I have to check and see if a perfect square will also go into 57. So you have to take 57 and divide it by the perfect squares to check and make sure that there isn't another one in there. All right, so your perfect squares again, right? 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225. Everybody okay with that? Yes or no? And then everybody okay with once we get the 4 times 57 here, 4 inside the square root becomes a 2 outside the square root, and then we reduce the fractions like normal. Are there any questions on this process? Yes, ma'am. What is the square root of 4? So that's what I mean is like if I have a 4 inside the square root and I pull it through the root, I have to actually take the square root of it. So the square root of 4 is my 2 outside. So everybody good? Yes? No? Maybe? 15. What's 15 say? Minus 3s. Okay. Is this in standard form? No, I need to make it in standard form, right? Now there's two ways of doing that. I can move the s squared from the left to the right, or I can move everything from the right to the left. Again, one of those people that when I was taught this stuff, we would lose points if the coefficient on our squared was not negative. I don't care. Okay, you can move the s squared over by subtraction, and you should get the exact same answers. So there's actually two ways of doing this problem. Okay? So I'm going to move the negative 14 over and the negative 3s over. So how do I get a negative 3s to move from the right to the left? Add it. So I'm going to get plus 3s plus 14 equal to 0. Okay? If you set up your ABC properly, and you do this the other way where you get negative s squared minus 3s minus 14 equals 0, you should still get the exact same answers because all of the negatives will cancel out. All right, everybody good with that, yeah? Okay, so for this one, what's my A? 1, what's my B? And what's my C? 14, so I'm just going to plug in, right? So S is equal to negative B plus or minus the square root of B squared minus 4 times A times C all over to A. Whoops. To A. So S is equal to negative 3 plus or minus. What's 3 squared? 9. What's negative 4 times 1 times 14? What's negative 4 times 1? Negative 4 and negative times 14. Negative 56. Because B is the coefficient on the S. No, that's an S. And then 2 times 1 is 2. Everybody all right thus far, yes or no? So far it's just a substitute evaluate, right? Okay. What is 9 minus 56? Negative 47? Okay. So, based off of what we have right now, how many solutions am I going to have? Am I going to have 2 real, 1 real, or 2 imaginary? 2 imaginary, which means that I'm going to get a number plus or minus I something, right? So, remember, what does I stand for mathematically? What is I equal to? Close, not negative 1, but the square root of a negative 1. Okay? So the only time we ever use I is when we have a negative in the radical. Everybody okay with that? So what we're going to do is we're going to replace the negative inside the square root with an I outside the square root. Like that, right? Any major questions so far? So now the number under the radical is just a regular old number, right? And I want to know, can the square root of 47 reduce? Which means, can I find a factor of 47 that's also a perfect square? So, what's my smallest perfect square? Okay, 47 divided by 4. Does that give me a whole number? No. Okay, so keep working through your list. What's the next perfect square? 9. Does that work? No. What's the next one? 16. 4 squared. Does 16 work? No. What's the next one? 25. Sorry, I thought you said 45. Okay, does that work? Okay, and look at my decimal. Am I less than 2? Then the only option left is if the original number is a perfect square. Is 47 a perfect square? No. So is there anything else I can do to reduce this? So I'm done. There's your 2 answers. Okay? So once you get here, you always have to check to see if you can reduce down that number in the radical. Sometimes you can, sometimes you can't. Okay, but to reduce down a number in a radical and simplify a square root, the only way is if you have a factor of the number that's also a perfect square. Okay, everybody good with that idea, yes or no? So this is where your calculator is going to become your buddy. But you're going to have to know what the perfect squares are. So you need to know your list up to 15 squared. You've heard me say that all semester. Those of you that know it, this stuff, you just type it in. Those of you that don't know are stuck after step 2, and that's a problem. So any questions on 15? Are we good? All right. It makes the number inside the square root not negative, but I itself stands for imaginary. So this means that you're getting 2 imaginary solutions. One with a plus sign, one with a minus sign. Because we can't do anything. It's impossible mathematically to square root a negative. So we can't even simplify this right now. So what I'm doing is I'm rewriting the square root of negative 47 into that, so I can split it up into that. But instead of writing square root of negative 1 all the time, there's an entire branch of mathematics that uses this, so we've assigned it a letter. So the square root of negative 1 is equal to I. And we only do that just for ease of computation. So you don't have a square root next to a square root. But now that this is something that I can actually evaluate, now I can factor it down like I normally do because this is a real solution. Okay, number 32. What does 32 say? Plus 11 equals 0. Okay, directions here say find the determinant, find the discriminant, and then use it to determine the number and type of solutions that this equation is going to have. So, who remembers from yesterday? Which piece of the quadratic formula is the discriminant? The b squared minus 4ac, right? The piece under the square root sign. So, all we do is find this as a number, so I plug it in. So, is my equation up here written in standard form? Yes or nope? Yeah, so what's my b? What's my a? And what's my c? Okay. Oops, not 0. My apologies. There we go. So now we're just going to evaluate this. So what's 7 squared? 49. Negative 4 times 1. Negative 4. Negative 4 times 11. Negative 44. So our final answer, sorry, you were a step ahead of me there. So 49 minus 44 is 5. So this is my discriminant. So if the discriminant is positive, how many real solutions? 2. If it's negative, how many real solutions? 2 imaginary, so no real. And if it's 0, we get what? 1 real solution. So for this one, we're going to have 2 real solutions. And this is all they want. For their answers, they want you to show them what is the discriminant, what is the value of the discriminant, And then use that to determine how many solutions and what type. If the discriminant is positive, it's 2 real solutions. If the discriminant is 0, it's 1 real solution. If the discriminant is negative, it's 2 imaginary solutions. So we're just using this number, and it'll determine how many solutions and what type. Yeah, so if you look over here where we had the I, what's the number under the radical? Negative, right? So that means that we get 2 imaginary solutions. Okay? Any other questions on the homework that you're still not sure of as far as type and what they want you to do? Everybody okay? Okay. So let me put the assignment back up. Here you go. Please get to work. If you have questions, ask.